Happy day to you all. I am Dr. P.K. Praveen Kumar, Professor of Department of Biotechnology, Sri Venkateshwara College of Engineering, Sri Perumbudur. Myself, I am a team leader for the Yukti Innovation Challenge 2023 sponsored innovation title called Ethanol a potent inhibitor of mitochondrial HSP90 of hepatocellular carcinoma. And my team members are Preeti, a PhD scholar, Actalin, and Nityashri are presently pursuing their masters in National University of Singapore and other in IIT Madras, but they are former alumni of SVC. And our UPI ID is IR 2022-773491. Yeah, related to the problem statement canvas. So the hepatocellular carcinoma is a primary liver cancer that is majorly caused because of hepatitis B and C infections, bad habits like smoking cigarettes and drinking alcohol, etc. And autoimmune diseases like diabetes can also worsen, worsen the liver to cause cancer. So the patients, generally of elder ages, have symptoms of pleiotropy of viral infection diseases. And so they also have autoimmune diseases, cardiovascular diseases, blood pressure. So this will increase the symptoms of the liver-based disease like hepatocellular carcinoma. And the problem actually present root cause of the problem, there is poor prognosis diagnosis during the early stages in the development of final stage of liver cancer, primary liver cancer called hepatocellular carcinoma. Just because we don't have a precision medicine, only 1 in 10 patients can be cured because of carcinoma. So, what is the emotional impact because of this proposed chemotherapeutic treatment? The present therapeutic treatment is treating the patients with sorafenib, which is a VEGF inhibitor. At present, the curing is very limited, so the mortality is high. And if we go for other alternative treatment, we can also go for HSP90 inhibitor of hepatocellular carcinoma called chloramazine, which is derived from microbial source. Empathy map canvas. So related to the carcinogens, 4-amino biphenyl, which is a byproduct of textile, dye, and rubber tire industries, have long been known to induce neoplasms at multiple organ sites in laboratory animals. Not only that, even NDEA, N-nitrosyl diethylamide, is a product of cigarette smoke, can also cause hepatocellular carcinoma. Then how to treat this? Obviously, we are bringing a novel strategy, that is bringing the drugs from the plants in the form of secondary metabolites. We are using a secondary metabolites to reduce the drug side effects and to even reduce the cost of treatment of hepatocellular carcinoma. Business model canvas. So if you see in overall, that is, these are the companies, Roche, Celgene, Bristol Myers, Johnson Johnson, Pfizer, AstraZeneca, Merck, and Novartis, are the popular biopharmaceutical companies bring the drugs for the treatment of hepatocellular carcinoma. As I earlier mentioned, in our laboratory, in our institution, Sri Venkateshwara College of Engineering, we cultivate the Indian ashwagandha, also called as Withania somnifera, in our soil, and then we isolate the fruits and we extract and purify the compound up to 92% purity level, and then we conjugate with nanoparticles for efficient drug delivery. So this is what we use as a drug for the treatment of the final stage of liver cancer, but it is better used for the treatment of the third and fourth stage of liver cancer of hepatocellular carcinoma. Now, let me go to the next slide. So, in the next slide, we are discussing on the opportunity canvas. In this, I'm discussing like what are the major targets we focus in our present research. In our present research, we are bringing a solution for the treatment of hepatocellular carcinoma by by targeting the prognosis and diagnosis receptor of hepatocellular carcinoma. That is, we are taking a precaution just before coming to the third stage and fourth stage before advancing to this middle stages of cancer, liver cancer. We can able to diagnose the hepatocellular carcinoma in the first stage itself through the prognosis marker like HSP90, which we call it as heat shock protein 90, or we can also you target hepatocellular, HSP75, also called as heat shock protein 75 or TRAP1, which is an important target for the prognosis and diagnosis. So this target receptor can be used uh, for targeting the hepatocellular carcinoma. Now let me go to the next slide. In this slide, I'm discussing about the stages of hepatocellular carcinoma. The first stage, initially the liver, can undergo NAFLD, that is non-alcoholic fatty acid liver disease. In the second stage, it can able to advance to the steatosis, and then it can advance to the fibrosis, and the fourth stage is cirrhosis, and the fifth, the final stage is what hepatocellular carcinoma. So whatever drug we prepared in our laboratory can able to treat in the third and fourth stages of liver cancer to avoid the personal fatality in the final stage of hepatocellular carcinoma. The problem statement. So actually, only 1 in 10 patients are cured in treatment of hepatocellular carcinoma. Our first innovation, that is proposed innovation, is to target only cancer cells, but not the healthy cells. This is just to avoid the pain for the patients and also to reduce the side effects of drugs. So mitochondrial targeting, of course, is a novel drug delivery technique which can target only the cancer cells and not the healthy cells of mitochondria in liver. And similarly, if you see the proposed second innovation is to target the early prognosis and diagnosis receptor like heat shock protein 90 or mitochondrial heat shock protein 90, also called as TRAP1. And the third proposed innovation is to establish the method or protocol to lower the cost of isolation, purification, and characterization of the drug, which is ethanol A, also called as a steroidal lactone, a diterpenoid, and also a secondary metabolite from Indian ginseng, also called as Withania somnifera. The fourth proposed innovation is to conjugate ethanol A, that is purified ethanol A, with biological degradable nanoparticles for efficient drug delivery and increase in bioavailability of drug for the HCC patients. The solution. So ashwagandha, which belongs to the family Solanaceae, is a popular Ayurvedic Indian herb found to have anti-tumor, anti-inflammatory, anti-arthritic, anticoagulant, and antioxidant, and also anti-diabetic activities. If you see the global ashwagandha market dynamic, that is current annual growth rate, so you can able to see the compounded annual growth rate comes around 115 million United States dollars by 2030 because of high demand. So we are actually taken steps to collect the seeds of ashwagandha and to grow the ashwagandha in SVC soil, and then we take the roots for extraction, as earlier mentioned, to reduce the price of the synthesis of drug. And similarly, if you see the product, our major product is vitronidale loaded nanoparticles. So this is used for efficient drug delivery, as earlier mentioned. We generally go for the target of HSP90. So if you see the mechanism, so whatever vitronidale loaded with the nanoparticles, so if we inject it, so obviously it is going to target the mitochondria. So in the mitochondria, you can see more vitronidale loaded nanoparticles can target only the diseased tissues and not the healthy tissues of the liver. And if you see the mechanism here, the mechanism is generally HSP90 molecules in closed state binds with ATP molecules. But in the closed state, it binds with the ATP. In open state, it don't have the ATP molecules. So it is clearly inferred that two ATP molecules are bound in the closed state of HSP90. And these ATP molecules binding with the HSP90 are competitively inhibited through the HSP90 inhibitor called vithnot A. The vithnot A, whatever secondary metabolite extracted from ashwagandha, can function as a competitive inhibitor. And obviously, you can able to find the just because of unbound of ATP molecules, the cancer tissues will gradually try to diminish. That is going to undergo apoptosis. And in the market, the present HSP90 inhibitor we use is the cheldanamycin, which is slightly hepatotoxic in higher doses, and it's an expensive because it's derived from microbial source. And the price of 1 milligram of this drug is around 95,000. And if we go for 10 milligram of the drug, the expense comes around 9.5 lakhs, which is very expensive. And if you see there's an opportunity given us to get a drug with lower cost. So myself, I will be taking ashwagandha root powder. That is, even we take roots and we ground it, and whatever we ground, we take it for extraction and purification, and finally the purified product, the expense comes around 10,000 per 10 milligram, which is comparatively cheaper when compared to the standard available in sigma rich milk. The 10 milligram of the vithanol A compound expense comes around 88,000. So this is a picture we have already shown as a prototype in Yukti Innovation Challenge. And in the next slide, we can able to see that the product is developed in SVC, or the product name is vithanol A loaded chitosan nanotruck. So we just cultivate the ashwagandha plants through the seeds, and then we take the roots, we ground it to the fine powder, and the root powder soaked with methanol. We go for cold extraction. We can also go for oxalate extraction for extraction of the product, and the filtered extract further is taken for various chromatography analysis, like it is taken to the TLC, and then it is taken to the column chromatography, and then finally we go with HPLC for purifying it as a final product. Now, after purifying the hair with nod A, with the different purity levels from 50, above 50 percentage, above 80 percentage, and above 92 percentage grades, we take this with nod A of various purity levels, and we also characterize the compound through HPLC. The third step is to take the purified ethanol A and we conjugate with the chitosan nanoparticles. We go for the synthesis using lean synthesis technology. We centrifuge the supernatant and we take the ethanol loaded nanoparticles, and we can also analyze the nanoparticles through drug, that is by measuring drug loading efficiency through UV spectrophotometer. Whatever we got as a final powder, that is ashwagandha vithanol A loaded nanoparticle powder, we also go for characterizing the particle size through the Zeta analyzer and determining the size distribution through the dynamic light scattering. So all these facilities are available in SVC. Now, obviously, I have incubated my uh, recent startup company, that is Phyto Nanostruct Technology, which is sponsored by Yukti, AST Yukti. So we are just focusing on these products in SVC incubation center. And this is the overall methodology. So, like we start with the isolation, purification, characterization, and then we check with all the computational studies of the binding of ethanol A with the target receptors, and we check the system biology approach by checking the HSP90 and HSP75 interacting protein, and we also check the binding affinity and binding affinity with respect to time through talking and simulation analysis. Then we tried with the in vitro studies, like going for cell culture with hepatic cell lines, and then go with the colony viability assay, colony formation assay. And we also isolate the mitochondria and assess the quantity of ethanoate accumulated in hepatic cells. The gene expression measurement of mitochondrial HSP90 is also measured using RT-PCR experiments. Not only we limited up to the in silicon in vitro, we also worked on the in vivo studies. So on in vivo, we assess the toxicity of the compound, and then we have assessed the various biochemical parameters like assessing ALT, AST enzymes on the effect of ethanol in mice. Later, we also measured the gene expression through the RT-PCR. So this is now obviously in vivo protocol, we have followed this step, and this is the overall methodology as I previously shown. And from the AST Yukti 2.0 sponsored startup is going to be established in December 2024. And the name of the company, the proposed name of the company, and approved name, Phyto Nanostruct Technologies Private Limited. So I thank AST MOE's Innovation Cell for sponsoring 5 lakhs for the innovation as well as for the training purposes as well as for the publication of patent and bringing a startup company. And myself, Professor P.K. Praveen Kumar, is the founder and chief executive officer of this company. And Mr. Jay Preeti is the chief technical officer, and Mr. S.C. Atul is the chief financial officer. And we all three are the board of directors for this proposed company. And this is a picture shown from the SVC Incubation Center. And this is my contact ID. And if you see the milestones of AST IFTI funded innovation, this innovation, I'm working from 2012 onwards, but the funding, the major funding I got from December 2021 through DST, through ANRF TARE funded fellowship. So in this funded project, okay, so I have focused majorly on the isolation, extraction, purification of ethanol A on hepatocellular carcinoma. So I generally targeted on mitochondrial targeting, but in AST Yukti funded innovation, I'm majorly focusing on bringing that purified ethanol A conjugated with different biodegradable nanoparticles through green synthesis technology. So that's the only thing I made for efficient drug delivery and to increase the bioavailability of the drug. So Yukti phase innovation phase 1 to phase 4, I just working on this period. And Yukti grant first installment utilization has happened from April 2024 to December 2024. And the synthesis and calculation of the drug we started on April 2024 and going to complete before December 2024. And we request presently for second installment utilization. The startup is established during the period October 24 to December 2024. And these are the competitive companies for the drugs manufactured for hepatocellular carcinoma. So our product is with ashwagandha plant-derived secondary metabolite with which will be conjugated with nanoparticles. So the business model. So we have proposed a methodology to produce different levels of purity of the ethanol drug, and we load the nanoparticles and we try to sell it to the B2B customer companies like Sigma Aldrich, Patanjali, Himalaya, Power, Vaidyanath Sali, Ayurved, Krishna's Herbal and Ayurveda, Organic India, Sri Sri Tattva, Amway, Kapiva. traction. We didn't receive any business traction, but we just developed the method to produce truck up to 92% purity and comparatively more yield than the yield reported in research publications. So we are also trying for getting an MOU with a director of a company called Canberra Therapeutics, which was sponsored by Iraq to big grant. The research mobilization plan. We have procured raw materials like seed solvents, reagents, and for preparatory HPLC and other techniques. We also require money for testing the drug in clinical trials, which we already worked in preclinical trials. So, for your information, we have completed our innovation and we advanced up to TRL 7. We have completed the technology readiness level 6 after getting funded from AST. So, actually, as I earlier mentioned, we had an incubation in SVC campus because the incubation center name is SVC EPIC. And we are trying to link with the startup companies and angel investment companies to scale up the drug production. So, a few recent publications on hepatocellular carcinoma are shown in this slide. And these are the publications made in 2024, which is more related to the innovation. So, both the quality papers are published in Springer Nature journal. So, in both the papers, I am the corresponding author. And these are the recent patterns on liver cancer. And these are the recent news in 2022 that myself, as a team leader of Yukti Innovation Funded Project, I received first prize on the oral presentation when I've gone for presenting the innovation in any engineering college in Vishakhapatnam. And I also received Young Scientist Award for a oral presentation on the topic mitochondria targeted nanomedicine for the treatment of hepatocellular carcinoma in the International Conference on Advances and Applications of Biotechnology, which was sponsored by TNSST, Government of Tamil Nadu, Department of Science and Technology, Government of India. So myself, I already introduced the team, the major team members, and actually, we thank the EST, that is ANRF, and also I thank AST, a Minister of Education, MOE's Innovation Cell, MICs, for sponsoring us to bring the innovation from advancing technology readiness level from 4 to 6. And these are my contact IDs, and these are my contact phone numbers. And my LinkedIn profile is shown here, and team leader profile. This is from a profile from SVC website, and the startup company website URL is also shown here. So I thank once again MOA, IAC, ACT, and the team for providing me an opportunity. So thank you very much. Bye.